Hi there, my name is Bonnie. I'm from Orkes. I wanted to walk you through this use case example that we are looking at in the screen. This use case is for alerting using third-party systems such as Pagerduty, OpsGenie, or other similar systems that you can do with Conductor Workflows. Conductor is a powerful orchestration engine, and oftentimes alerting is nothing but orchestrating a bunch of steps. Typically, alerting will look at some data set either through an API or your own database. You will poll this data set or that API periodically, and depending on what you find from that polling event, you might fire an alert. In this example, we are going to be polling a URL, and that URL will be polled periodically, and whenever there is a data that is found in this endpoint that signals that there is some failures that someone needs to take attention to, we will fire an alert through systems like PagerDuty or OpsGenie. There is no specific regards to the actual systems that we are alerting on. At the end of the day, we are looking at systems that we could integrate with using concepts such as webhooks or API calls. So in this example, we are actually going to query Conductor itself. And that is an intriguing way because oftentimes you're running workloads on Conductor and you want to track when workflows are failing or if tasks are failing, etc. So when workflows are failing, the state of the workflow switches to failed, and you can use a sliding window technique to scan for failed workflows and use that information to subsequently alert on any of the third-party systems we use. So typically, this alert design that we see here in this diagram is similar to what Elasticsearch and Kibana does. It takes a sliding time window, or every minute or so, it'll scan the data. And in our case, we are making an API call. And whenever there is a failure that is found, we will then inform PagerDuty or other systems which can trigger alerts to the users who are monitoring this. Let's have a look at the workflow that actually can do this. So here it's pretty straightforward. Just like our design, we're computing the time window, we are querying the endpoint, we're checking if there are failures, and if there are failures, we inform on Slack or we inform a system like PagerDuty. This is the actual definition of what you saw of the picture above. There is a JavaScript task that computes the start time and end time. There is an API call, and here we are querying Conductor server, the server that is actually running this workflow itself. It could be a second Conductor cluster that is querying the main Conductor cluster, but since this is application level monitoring, you can actually do that within the same Conductor cluster. So here we are just using the internal URL of the Conductor to make the call to the search API, very similar to how you use the UI, and the start time and end time is parameterized. So every time this workflow runs, it is actually running against the parameterized value of start and end, which is a sliding window of whatever time frame you would like to. We are also passing the API key. So this API key should belong to an application that is able to scan the specific workflows you want this alert to scan through. We're also using a concept called as output filter, where we compute a value based on the output of the HTTP task that we have here. So in this example, what we're doing is we are querying the same task output and then filtering it down to the response body results, and then using the JSON path expression of length, we are basically identifying the number of records that are returned under the results JSON object key. And then we have a switch task which checks if the JSON object key that we have created here is actually null, or is it greater than 0. If it's null, that means there is no results, or if it's 0, there's no results. If it's null, actually it could be a problem that happened, so we are including that condition. But if it's greater than 0, that means there are error records that you want your developers to look at. So that is the condition for the switch. And if the switch condition is true, we are informing on Slack and calling systems like OpsGenie or Pagerduty. So this workflow is now complete, and if you run it manually, it will check the last window that you specify and extract the results, and then invoke the API for alerting users. This is an example of how PagerDuty can be invoked. This is the payload format of what PagerDuty accepts. You can compose similar payloads for the corresponding system with the flexibility of using variables that can deep link back to your conductor instance for the same query that your alert is using. That way, when somebody gets an alert, they can deep link into the same exact alert result set by deep linking. So now we have got this workflow. Conductor has a scheduler feature that allows you to run it at a periodic interval. It's pretty easy to configure that. So you configure a schedule and say that you need to run this every minute. There are secrets that we use in this, and that can be managed using the secrets function in Conductor cluster. And specifically for the API token that we use for Conductor queries, this is an expiring token. So you could use a concept called as update secrets, again using a scheduler. There is a dedicated article for this on how this works, where you can keep that token up refreshed using the permanent secret and access key that you have for your application. And this is a workflow for doing that, and it's got the description to do so. So let's have a look at this workflow. So this workflow now runs, based on your periodic failure, based on the configuration that you've made. And each time it runs, it computes a sliding window using the first task, runs the query, and wherever data is found, it informs Slack or OpsGenie. It's pretty straightforward. This offers a lot of flexibility because now you can configure your alert to be very customized. You can even scan specific failures within the workflow payload. Like you could scan for the presence of certain keywords and only then inform on Slack, and optionally only inform on OpsGenie if this particular failure warrants it. So you can have like highly customized alerting mechanism that is really flexible, that you may not get from systems like Elasticsearch and Kibana using Conductor's orchestration. Thank you.